Glad I can help.
The age century. Why don't we go ahead? It's 7, I guess, after 7. So why don't we go ahead and get started? First of all, welcome everyone. Want to thank Russ for taking the meeting. Seems like it wasn't exactly last month, but it was a few weeks ago. So Russ, I appreciate that. I guess as we usually do, let's go ahead and do a round of introductions. My name is Doug Gooden. I'm the NECAL president.
Dave Cromer, treasurer.
Sam Pomeranz, I survived Amsterdam and Paris. I just got there.
Okay.
Wes Giles.
Almost.
Tony Castaneda.
Would you like to introduce yourself?
Sure.
Yes.
Tracy Gillespie.
Janelle Berger.
Angel Romero.
Chuck Green.
Glenn Kress.
Gary Hood.
Russell Valentine.
All right. So again, welcome. I see a few at least newish faces to me, so that's good to see. So when did you get back from?
It's about 2 weeks now.
Oh, so it's been a while. I used to think when I did a lot of international travel early in my career, and I always thought of myself as kind of like a probability distribution, somewhere between here and somewhere, and where I was on that
I got an
distribution.
interesting picture. It's not. It's typically. It looks like a flying saucer. It's not. It's an optical thing. There was a big storm coming. Coming back from New York to Kansas City. Big storm, and I think a lot of ice crystals. So I took some pictures out of the window, and I enlarged one, and it looks exactly like what they claim is flying saucers. It's not. It's an optical.
We should do a thing on that sometime.
I just gave a.
Were you
Yeah,
close
I
to-
just gave a talk on UFOs to our atheist group.
Okay.
Were you close to Devil's Tower at the time?
No.
Only people that remember that movie will know.
Well, we
You're
had
old.
Yes.
the month before, and keep an open mind on this, I'm a skeptic, but this lady claimed she was abducted by aliens. And there's a psychiatrist, Mac, from Harvard, that wrote a whole thing on it. And I observed her carefully. She wasn't lying. I mean, she really experienced something. I don't think there are aliens. I don't believe that as a psychiatrist. But I think it's worldwide. Some people get up these altered states and they're convinced they're been abducted.
Yeah.
Drug induced or not.
So I told her, we went out for dinner afterwards, and I said, tell the alien Sanford Pomeranz wants to be abducted.
Wants to be abducted.
Just to check
I just
that.
wanted
Yeah. Well, I don't know. I guess I take a lot of that with a grain of salt, but you want to keep an
It's a
open
mental
mind.
phenomenon. They're experiencing
I
something that's worldwide.
I remember, I can't remember the exact context, but I happened upon a map of Bigfoot sightings in Kansas. And what was interesting to me was that they were all late Friday night or early Saturday morning near roads. And I was thinking, the drunks are going back from,
Near taverns.
And-
Yeah.
they happened to see a dog and thought it was
Right.
All right, well, welcome everybody. Again, this is our kind of little bit of out of time sequence meeting because we don't want to compete with the holidays. So I'm glad you were all able to make it. Just a few announcements. There's not that many because we don't actually have a meeting in December. Instead, we have something else, which we'll talk about here in just a second. So the one thing that I wanted to make sure we got the word out on is that there is a public night this Saturday at Far Point. I believe the forecasts are pretty good. Sky forecasts last time I looked at it was like 12 hours ago, and it seemed reasonably good. So I don't know, maybe
It's
The early part of the evening.
around 10 or 11.
Probably
some
okay.
yeah.
Clouds that right now are supposed to come in.
So if you are wanting to come out and join us, if you're we always have work to do or jobs for people, but if you want to just come out and observe, that would be good too. And I think this is the last public night until like April, right, or something like that.
All right.
So, because we don't like to do it when it's cold, because it's cold, right? So, anyway, so that's
Smarter over the years.
yeah. I understand there are people that my first sort of first job was as a meteorological observer in Rock Springs, Wyoming. Which I don't know if you've ever been to Rock Springs, Wyoming, but it's cold.
Sadly, I've been there.
And my job was to go out twice a day, including once at like 5:30 in the morning, and send up a weather balloon, which you had to sit there and watch with this little telescope, you know, it had this little light in it, and the radio sound, the thing that hangs from it that actually sends back the data. You have to watch it to, you know, and it's so cold that your eyes water and then freeze to this little telescope, and to kind of stick yourself. So I kind of figured that was what made me realize I really didn't want to be a meteorologist, despite having spent, you know, years in college learning how to do it. But anyway. Okay, so these are, I guess that's it for announcements, although the big announcement, of course, is it's almost that time for the leading event in the social calendar for, I think, the entire city of Topeka. It's our Christmas parties, December the 2nd. That's a Saturday, 7 p.m. It's at the same place it always is, Gage Park, Snyder's Cabin. It's a potluck, so please bring a dish to share. There will be at least one award. It's a secret.
Yeah, well, there's a few others coming up.
And there'll be a few others, I'm sure.
I think.
So yes, should be a lot of fun. So if you're here and you're available, please.
You might talk about the election forms.
Oh, that's right. Yes, and that's also when we announce the results of the election. So you should have gotten an email with the ballot attached, right? And if you want to vote in the election, you should return that, and it's just to elections is the email. So it's elections
At NECAL.
.org. Or you can bring your ballot with you to the party, but what we need to get it like early so that all the votes can be tabulated and all that sort of thing. So if you wanna vote in the election, please get that to us sometime before or at the Christmas party. Anything more we need to say about that?
I was just gonna say that the board provides drinks and like cutlery and stuff like that.
Right.
You know, so you don't have to bring your own forks and spoons and whatnot. Yeah.
And some awful chili.
Yeah.
Get
Is it
that.
gonna be the chili? Okay, do I have to bring the awful mac and cheese again?
I think you do.
Well, let
I mean,
me.
it's pretty much required, isn't it?
Well, I kinda figured that, but I just wanted to see if I could get it.
That's good to know, because we're still thinking on it, and one of our options was Mormon potatoes, which is actually pretty close to mac. It's like potatoes and cheese, so we may
Hey,
want
but
to
the cheese.
rethink
cheese
that.
is-
but-
No, just do that, because, you know.
I want to add that on the election form, you're voting for board members and then a few officers, and you may not know who they currently are because we don't see all of our membership. And if you go to our webpage under About Us, it lists out who's our officers and then our board members. Most of us have pictures up there.
Yeah, and the board vote is like a rank vote, right? You just rank six, I think six, right? Six.
9, you need
Nine.
extras.
Okay.
So 9 to 12. It says on there how many. I think it's
Okay.
actually more than that. It's
Okay.
12 or something.
All right, so any other announcements or news or anything that we need to?
The public night's going to be sort of unique because we just switched our clocks. So we actually start our board meeting at 5:30,
That's good to know.
which means that the sun is down and it'll be dark while we have our board meeting. But the public night, which many of you said you're coming out to help us, starts at 7. So if you come out a little bit early to set up your scope on the pad, or you want to sit and watch us at a board meeting, you'll likely be doing it in the dark a little bit.
Which would be riveting, by the way.
We've been in the dark for many things over the years.
Okay, so anything else, announcements-wise? Okay, well, I kind of go back and forth on including news items because, of course, Jan does such a great job of sending those out every day. But there was a couple of them I thought might be kind of interesting to point out. First of all, Jupiter is in opposition this month, and that should be a pretty good target to take a look at Saturday night. So that should make for good viewing. So hopefully we'll get a good look at that. I have a friend who is kind of recently bought a telescope and has been shooting stuff, and he got some really nice shots of Jupiter already, so that should be a good thing to see. Another thing that I just thought was kind of interesting, I think this was in one of the things that Jan sent around, is, the moon now is kind of inside the teapot. At least it will be tonight. Of course, we won't be able to see it because it's pretty cloudy out there. But I don't know, for some reason that struck me as kind of interesting, that the kind of new moon, waxing now, is inside that little asterism of the teapot, which is in the way I've always found Sagittarius. So, unfortunately, we'll miss this, but because of the clouds. But thought I'd point it out there anyway. Another thing that actually we sort of we're a little bit past the prime on this, but I don't know if any of you have ever seen Uranus, but I have not, and it's a planet that under certain circumstances you can pick it out with the naked eye. It's magnitudes like 5.8 or something like that. But it was kind of easy to see during the dark sky period just recently. So it was at opposition too. So that made it easier to see. It's probably still possible to pick it up. It probably would take a telescope to.
It's out Saturday night.
Yeah, so it's another one.
Jupiter and Uranus are going to.
It's another one that we might be able to get a shot at. I think it and Mercury are the only ones I've never actually seen. So I'll be kind of looking forward to that.
It's mostly identifiable by its color.
Yeah, it's kind of
It's got
bluish,
a
right?
bluish color to it. So.
Yeah. Apparently, there are people that I probably can't, but there are people that if you're in a dark enough place and your eyesight is good enough, at a time like this, you can pick it out. But I don't think I could do it. But anyway, that's another thing that probably should be visible. Here's another one. If you're tired of looking at stars and planets and moons and all, and you want to look at a tool bag, there is now apparently during a recent spacewalk from the International Space Station, the astronauts dropped their toolkit, or I don't know if you can truly drop anything in space, but and apparently this thing is visible now. It shows up as a 6th magnitude object, which would mean that under ideal circumstances you could see it with your naked eye, but you'd have to have really good eyesight, have to be really dark. But apparently with binoculars it's pretty easy to pick up. It looks like a little glowing dot just about a second ahead of the International Space Station. So if you find a time when there's an ISS overpass and you get a chance to watch it, you could actually see, which makes me wonder.
It's going to fly
this thing,
over Saturday night.
This thing must be just made out of incredibly bright material, because a tool bag can't be that big. I mean, it can't be like the space station is big, right? It would fill a football stadium, but I can't imagine this tool bag is quite that big. So anyway, this could be an opportunity. I also kind of wonder if NASA is going to dock the pay of those astronauts.
They lost their tools.
They lost their tools.
It's not the first time it's happened.
Their paycheck. Yeah, they're going to have a lighter paycheck this month because
Can't
they
they
have to.
recover it?
I probably wouldn't be worth it. The amount of the complexity of the spacewalk that it would take to do that it would cost millions of dollars to.
There's a really high ISS passover Saturday night at 6:08.
Okay, so we could get a chance to actually, if it's clear, we
Get some binoculars, might see a little dot in front of the space station.
might see the tool bag.
There's
Yeah.
actually one tonight by Sagittarius. You can
Really?
saw the
Oh, yeah.
moon and ISS.
And the tool bag, all at the same time, except for the
Alien
clouds.
tools.
So anyway, I thought that was kind of funny. So I thought I'd throw that one in there too. Okay, so
Yes.
constellation of the month. I was trying to think of ones that we hadn't done, and I kind of settled on Taurus. Because I've been on a little bit of a trend of doing some of the zodiacal constellations, so this is one of those. So I figured I would talk a little bit about Taurus. Turns out its story really isn't quite as interesting as some of the ones we've looked at. Some of them have very colorful stories. Taurus has a story, but it's not as colorful as some of them. But nevertheless, kind of a constellation with some interesting stuff in it.
It's just a bunch of bull.
Just a bunch of bull, yeah. So there's Taurus right there. This is actually what it looks like I think I set this for 7 o'clock, so this is what it looked like 17 minutes ago. there's Taurus right there. It's kind of to the northeast, east-northeast. You can see it's kind of rising there. One thing to notice here is that at least at this particular time, Taurus is rising sort of upside down, right? It's head down, basically. So it's rising kind of tail first. So there it is, right there. Still relatively low in the sky. How to find it? It's, I think, actually one of the easier constellations to find. It really only has only a couple of really bright stars in it, but it's kind of easy to find as far as I'm concerned because the Pleiades are actually considered to be in the constellation. You know, when the International Astronomical Union draws the boundaries, the official boundaries for what's in and not in a constellation. Turns out the Pleiades are actually considered to be in Taurus. So if you want to find Taurus, just find the Pleiades and then look for the bright star that's kind of, unfortunately, this is not how it's going to look for us. It's going to look more like this, at least for now, but you'll be able to find. So the kind of distinctive parts of this, you know, we often comment on the fact that constellations rarely look like the thing they're supposed to be. And I don't know, I guess I can kind of see that this looks like the head of a bull with its horns sticking up there, right? The second brightest star in the constellation Alnath actually refers to that. It means the butting, which is the horns of a bull, right? The thing it butts with. So that part of it kind of makes some sense. But this part down here, I don't know. It looks to me like not a bull, to be honest with you. But anyway, this particular constellation, like a lot of them, has been recognized as something like an animal for a long period of time. You know, most of our constellation lore, at least the part that we are kind of most familiar with, comes from mostly Greek mythology. And so the mythology of Taurus I'm going to talk about here just a little bit comes from the Greek. But there's a lot of traditions of it being a bull or an animal of some kind. So that just kind of probably tells you that knowledge gets passed down, basically. So here's another way to find it once Orion is a little bit more prominent in the sky. Orion's belt points almost, not exactly, but almost toward Aldebaran, which is the brightest star in the constellation. It's actually one of the brighter stars in the sky. I think it's number 14 in terms of magnitude. So that's another way once we get a little further into the kind of winter sky and Orion becomes a more prominent constellation. Orion, by the way, is one that actually does look like, at least somewhat resembles what it's supposed to be. So anyway, that's how to find it. As far as the story goes, as with a lot of these stories, it has a rooting in Greek mythology, and in particular the Greek gods. Of course, the leader of the Greek gods was Zeus, and as we've seen numerous times now, Zeus and his fellow gods and goddesses were not especially well behaved. And in this particular case, Zeus became kind of infatuated with a young woman who was the daughter, actually, she was a princess of Minerva, right, of present-day Lebanon, basically, and became quite besotted with this woman who supposedly was the most beautiful in the world, and decided that he would pursue her. But his method of pursuing her was to turn himself into a bull. And because she was worked with the herds, right? She was a herdswoman, I guess you could say. So he turned himself into this marvelous white bull and ingratiated himself with her, and then essentially took off with her. Depending on which part of the story you read, he either kidnapped her, he either lured her away or kidnapped her, depending on how you look at it. I guess Rembrandt thought it was a kidnapping because he entitled his painting of this event "The Abduction of Europa," and there you can see all the concern over here is the bull of Zeus carries her off. They ended up carrying her off to Crete, the island of Crete, which is, of course, kind of in the middle of the Mediterranean Sea, right? And so he installed her in Crete. This is actually a statue in Crete, which I did not take this picture. I've never been to Crete, although it looks like it'd be a really cool place to go, from what I can tell. But this is a statue that kind of shows the event, and you can see Europa there is on the back of the bull. He then revealed himself to be actually the god Zeus, treated her rather better than a lot of the women he abducted through the years. In fact, gave her, was apparently genuinely fond of her, gave her some rather spectacular gifts, one of which is kind of persisted in an odd sort of way. One of the gifts, so apparently he gave her these three great gifts. One was a hunting dog that always succeeded, right? It never failed to capture its prey. One of them was a spear that never missed, which, as it turns out, her son used to slay a monster, but that was a completely different story. And then the third one was essentially a robot named Talos. It was a large mechanical man, basically, that was to serve as a protector, basically. So here's where it gets a little interesting. Have any of you ever seen the movie Jason and the Argonauts? You've seen this movie before? It was early 60s. It was one of those stop-action animation movies, you know, and there's a dramatic scene in it where the Argonauts have captured the, whatever it is they're trying to get, the fleece, I guess, and they're trying to row their way away, and there's this huge, monstrous, mechanical creature trying, well, that's Talos. And Talos, to this day, is still considered by the people in Crete to be the protector of the island of Crete. In the Second World War, they actually had these planes that were defending, the British planes, defending the island from, I think, Italian invasion. And they were referred to as the Talos planes because they were the defenders of the island of Crete. So anyway, this story has kind of persisted through time. But the origin of Talos was as a protector of the goddess Europa, or of Europa. Of course, we also kind of keep Europa in the current astronomical thinking in other ways. This is the moon Europa, which is of course one of the Jovian moons. Jupiter is essentially the equivalent in the Roman god pantheon of Zeus in the Greek pantheon. It's not exactly the same, but it's pretty close. So they're still together, right? At least in the heavens, they're still together. Europa, by the way, is the namesake of the continent of Europe. Apparently the Greek, and I don't speak Greek, but the words that make up Europa mean something like broad-faced. And it was considered a compliment, right? It was a comment on Europa's beauty, but Europa became the namesake of the European continent. So sometimes in the mythology, at least the stuff I was able to find, Europa is referred to as sort of the godmother of Europe, basically. So anyway, so that's the story of Europa and the constellation. As far as interesting stuff to see in the actual astronomical constellation of Taurus, there he is right there. You can see the brightest star, Alpha Tauri, is called Aldebaran. Aldebaran actually means the follower, because Aldebaran follows the Pleiades. And you know, there's a whole mythology associated with the Pleiades too. But Aldebaran follows the Pleiades, Alpha Tauri. It's a red giant star, the class of star that kind of, if you look at the HR diagram here, it's off the main sequence. It's up over here in the red giant. So that's how big it would be relative to the sun. So very large, very old star. The other kind of bright star in the constellation, which is right there actually, is Elnath, which means the budding, as I said. And budding in this case means horns, right? So the horns, apparently, it's a kind of an archaic term for the horns of a bull. So it lies along one of the horns of the bull. It's right there, and it's a B-type star. So here it is in the Hertzsprung-Russell diagram. It's kind of over here towards the larger, hotter, kind of younger stars. there it is relative to the sun, not much larger than the sun, but not anywhere close to the size of a red giant like Aldebaran. So one of the things I thought was interesting about Elnath, though, is if you go look at it or look toward it, you're essentially looking towards the galactic anti-center. You're looking out of the galaxy. All right, so if you look back in the opposite direction, which you can't do right now, you're looking toward the core, right, into the Milky Way. This would be looking out of it. So if you want to look out away from the galaxy, this is a look towards Elnath, towards Beta Tauri. Okay, so other interesting things, of course, the Pleiades are considered part of it. Pleiades, again, has a rich mythology all of its own, the seven sisters, of which, can anybody here actually see seven stars in there?
Used to.
Used to? Wow. Almost, I have only, and I've tried, since the time I was probably about 12. Tried super hard to see seven stars here, and with the naked eye, and I can't. There's thousands, actually it's a cluster of probably about 1,000 stars, right? They're relatively young B-type stars, new, hot, kind of relatively recently formed stars. But I can ever only see 6. And there's actually some stories that kind of center around that, what happened to the 7th Pleiades. Pleiades is kind of an interesting name, at least to me, in that the original meaning of it was related to sailing. And the reason for that was that the time of the heliacal rising of Pleiades, at the time when it first becomes visible after the solar new year, basically, was also the beginning of time when it became safe to sail on the Mediterranean Sea again, right? It was basically kind of good sailing, the harbinger of good sailing weather. And then it's sort of, in mythology, the Pleiades are these daughters of Pleione, right? One of the water nymphs, basically. They think that might be kind of a retrofitted myth, and that the name itself derived from this earlier association with sailing, which, I don't know, for some reason I thought that was kind of interesting, so I threw that in there. So Pleiades, M45 in the Messier catalog. And there's also we just came through Halloween, right? I still have a couple of pieces of Halloween candy left. There's an interesting association between the Pleiades and Halloween, too, which I understand has nothing to do with Taurus, except that it's in there. So Halloween is very close to what's called a cross-quarter day, right? So we know about the solstices and the equinoxes, right? And they're referred to as quarter days. They're marked the quarters of the year, right? And a cross-quarter day then is halfway between either a solstice and an equinox, or an equinox and a solstice, depending on what part of the year you're in. And so the Pleiades reach their culmination, they reach their highest point in the sky right about at the autumnal cross-quarter day, which is also just about the time. It was actually, Halloween derives from a holiday called Samhain, and Samhain actually happened a few days after we now do Halloween. It was more like about the middle of November, and so that's kind of marks that cross-quarter day. So it became kind of a significant thing in the calendar, right? A lot of these days that we recognize as associated with seasonality were used as for agricultural purposes, right? Planting and determining those sorts of things. So there was this kind of interesting relationship between Pleiades and Halloween, which I thought I'd throw that in there too. Of course, the other kind of famous site that's located in Taurus is the Crab Nebula, M1 in the Messier catalog. Crab Nebula kind of has an interesting history. It's a supernova remnant, and it's one supernova remnant that's thought to, it's not ever really been conclusively proven, but it's thought to have been observed and records kept of it. There's actually some pretty good records from China of it, but there might also be, and again, I throw this out there with a little bit of caution, because this has never been, despite what you might see in occasional archaeology books, has never totally been proven. But it could be that there's a record of it in rock art in Chaco Canyon. So if you're familiar with Chaco Canyon, it's a archaeological area in northern New Mexico. It was part of the Anasazi culture, the same people that built cliff dwellings and that sort of thing, or at least precursors of those people. And so here's that thing right there, and this thing right here is supposed to perhaps represent the Crab Nebula. So this would have been something probably visible even in daylight when I think the date on this would have been sometime in the 11th century, 10 something, basically.
1071.
1071, yeah. So this would have been visible in daylight probably during that. So this is what the remnant looks now. This is a composite in a bunch of different wavelengths. Here's the actual wavelengths down here. So you can see there it is as a radio object. There it is as an infrared and an optical and an ultraviolet and an X-ray and so on. The other thing that's kind of interesting about the Crab Nebula is it's got a pulsar in it. The pulsar is actually the remnant of the star that went nebula, right, or went nova, right? So what happens in a nova is in a star, the forces that, the radiative forces that hold it up and the gravitational forces that want to smush it down are in balance through most of its life. But then late in the life cycle, when the nuclear fuel kind of runs out, star collapses. That basically causes heavier elements to fuse. They blow it back out. And what's left over when the core of the star is basically just a solid hunk of neutrons, right? It's a super dense remnant of this thing. If it's big enough and dense enough, it can become a black hole. But if it's not quite big enough and dense enough, it remains this neutron star. That still has all the radial velocity that was associated with stars, so it's still rotating. And since it's now much, much smaller, some of these things are probably maybe 40 kilometers across. They're quite small. Rotates really fast, right? And it also has the magnetic field. It retains the magnetic field that the star has. So it has a very powerful magnetic field around it. So what that tends to do then is direct these two streams of radiation out through what would have been the poles of the star. And if you happen to be lined up with these so that that beam is pointed toward you, it will kind of show up as a periodic radio signal. And that's what a pulsar is, the pulse, basically. The very first one that was ever discovered was discovered by some astronomers, I believe, at Cambridge University. And they freaked out. They thought this was some signal from outer space. They called it the LGM signal, the little green men, or something like that. Turned out not to be that, but and then the Crab Nebula pulsar was, I think, one of the second or third ones identified as a pulsar. So this just happens to be probably all neutron stars are pulsars depending on where you are, right? If you just happen to be lined up with those poles, then it flashes you and often very high frequency. So anyway,
One note,
yes.
this thing rotates about 30 times a second. If you set an LED and look at that LED with one eye and look at this pulsar with the other eye, you can actually get those to coordinate. And you can see the difference.
Wow, that would be
Pretty amazing stuff.
That would be freaky. Yeah, you should try that sometime. Anyway, yeah. So anyway, this is one of the more interesting objects in TARS as well. And of course, I'm always a fan of meteors, and I'm so disappointed because I found this cool website that was animations of what makes a meteor shower work, and I swear I'm going to have this for tomorrow night, or Saturday night, to show you guys because this was so cool. It showed what a meteor shower is, right? It's just a bunch of material that's been left behind, usually by a comet or some kind of passing object that's shedding material. And when the Earth passes through the stream, that stuff starts coming through the atmosphere, right? And it's usually really tiny little things. Most meteors you see in the sky are probably, grain of sand size as they pass through. They hit the Earth's atmosphere, they start ablating, super high velocity, so temperature gets really high. They start ablating, they start burning off, basically. And you get those beautiful colors, right? But anyway, I'm sorry, but the this animation, I can't find it. I built a hyperlink into this when I made this, and it didn't follow me here for some reason. But anyway, there's a couple of really good meteor showers. I'm a sucker for meteor showers. I would watch them all day or all night if I could. And there's two of them. There's the southern and northern torids, which are named because one is in the south and one is in the north. They're actually both associated with the stream of material. I believe it was Comet Inky is the comet in question. And we should probably be able to see some of these, I would think, Saturday night. They might kind of be a little bit in the sky glow from Topeka because they're kind of off in that direction. But we may be able to pick some of
Is
these
this the
up.
Leonids then?
Hmm?
Is this the Leonids?
No, this is torids.
Because
Yeah.
the Leonids, I think.
The Leonids they're kind of peaking, or
Yeah.
slightly past peak now,
Yeah.
right?
This weekend they do.
They're peaking this weekend too? Okay.
Morning or
They should probably be easier to see, I would think, because they're not back in the direction of the city lights.
The
I think
really
these might-
intense storms are kind of on a 33 plus or minus year cycle.
And this little animation will show you why that is. Yeah,
Because it gets a thicker straight part
it
of
just
the
passes
stream.
through a thicker stream, yeah. But they kind of pass through this stream of material, and I don't know. I think one of the only bolides, I know a bolide is a fireball that explodes, and I think one of the only bolides I've ever seen was associated with one of these. That's when a bigger, like a chunk of something maybe the size of a golf ball comes in. It's big enough to explode.
The last time that we were out at Farpoint, and Janelle probably remembers this, in 1997, there was a huge amount of them, and they were bright, and they were bolides.
Really?
And they were like every 15, 20 seconds, you see another big one go by.
Yeah.
So that was a pretty amazing thing. That's 1997. Calculate back now. We're getting close to that 33-year.
Maybe we'll
We're
get
not
maybe
quite
we'll get
there
some
yet.
maybe we'll get some big chunks then. Yeah, the one I saw was bright enough that for a very short period of time it would look like almost like daytime again. It was pretty amazing. So anyway, that's another thing to see.
Yes.
Okay, so Taurus. Any questions about Taurus? And if you've got a request, you got a favorite constellation, and if you want to do a constellation, please feel free to let me know, because I'm always happy to hand over the floor. Okay, so the other thing I wanted to talk a little bit about tonight was Aurora. And I kind of wanted to do this for a while now, because I think the Aurora is just an incredibly interesting phenomenon. And also because we're at a time now when Aurora should be a little bit easier to see. There's been some, here's an article from November the 9th that talks about stronger activity, stronger solar activity could bring some more Aurora activity. This is a picture, I guess, that was taken in April in Washington State, which, you typically think of the auroras as being a polar phenomenon, right? And there's reasons for that we'll get into, but they're appearing now at lower latitudes, and that's kind of an indicator of more solar activity. Here's another one. This one talks about, this is from last summer, but it talks about Pennsylvania and Iowa. Gary actually sent around a video. I don't know if any of you saw it. I tried to put it into this presentation, failed. But it was from the all-sky camera at it.
Yeah.
And do you ever, what do you think? Do you think that was an aurora?
I'm pretty sure it was.
Yeah, it was I don't know if any of you saw it or not, but it was a little video from the all-sky camera at Farpoint. Had a nice reddish, there was some clouds in there that kind of,
There was some clouds, but what was interesting was that the reddish glow was, and it's normally not there. If you go on different nights and stuff, you won't see that. But that particular night, that glow was pretty evident. And what happened kind of toward the end of that video file was there was some lower band that was actually shooting streamers across the horizon, the northern horizon, and it was pretty obvious it was moving across the north sky.
yeah, and that's one of the big indicators of aurora, I personally, I think I've seen an aurora once, and I was actually in Texas at the time, which was weird. Actually, I might have been in Oklahoma by then. We were driving home from Lubbock one night, and this weird glow off, and we were like, what the hell was that? And finally it dawned on us, no pun intended, that it was the aurora. And it wasn't a particularly good one. So I'm still, one of my bucket list things, if I have a bucket list, is to see a really good aurora sometime.
Back in the 80s, I saw one, I was up around Meriden, I think. I don't know why, but,
I don't know why I was in Lubbock.
but there was aurora that was actually, and Orion was rising up, and you could see aurora in Orion,
Really?
which was, you know, pretty far south to be able to
yeah.
see that, so.
Yeah.
It does happen.
Yeah. Well, and I think one of the things that just fascinates me about aurora is that, you know, kind of as a former atmospheric scientist, the atmosphere just really is interesting to me, right? But also just, you know, from purely from an aesthetic point of view, it's just an amazing thing. Of course, most of that, my appreciation of it comes from pictures like this, but you see these kind of pictures, and they really are just kind of just a fascinating thing. So the aurora actually, you know, we mostly think here in the northern hemisphere of the aurora borealis, which actually translates to mean the northern dawn, right? Sometimes it gets mistranslated as northern lights, but aurora actually means dawn. So this is the northern dawn. There's also the aurora australis, which is the southern lights or the southern dawn, but it's essentially all the same phenomenon. So there's a shot from someplace in New Zealand. This is Antarctica, actually, here. This is one of the research stations in Antarctica where apparently these things can be pretty spectacular. So obviously just a, you know, aesthetically just kind of stunning thing. So I figured I would kind of talk about it a little bit. Here's actually a shot that was taken in Stillwater, Oklahoma. And this was taken not that long ago. This was a couple of weeks ago, I think, or maybe about 3 weeks ago. So there's a nice red glow. This might have been about the same time you got.
I wonder if it.
It's the same night.
Yeah.
I sent that to you.
Yeah, and this is a kind of an amazing shot as well. So this kind of shows you that, you know, we typically think of these as polar phenomenon, but they're not necessarily restricted to the poles. So I hope this works. You know, when we look at static pictures like this, you kind of get an idea of the aurora. But I think what must be really stunning about it is if you actually can kind of see it in action. So I linked to this. This is a little video from Norway, 40-second. I didn't want the music, although it's not. But this is the thing that I want to see sometime. It's just that sort of scintillating, shimmering appearance. And that's also a real clue as to what causes the aurora. So what I want to do, first of all, is I want to just kind of talk about the auroras a little bit as a science phenomenon and an atmospheric phenomenon. But then I also want to kind of round this off by talking a little bit about the aurora as kind of a, you know, an object of art and an object of legend as well. So there's a nice little 40-second view of the animation of the aurora. Okay, back on the slides here. So what causes an aurora? What do you need to have in order to have an aurora? And like a lot of things, it's a fairly complicated question, but you really can kind of boil it down to three things. You need a planet with a magnetic field of some kind, or an object with a magnetic field of some kind. That object has to have an atmosphere. When I originally made this slide, I said it has to have a dense atmosphere, because I think that's the way I learned it way back when. But it turns out it doesn't necessarily have to be that dense. There's occasionally aurora activity that's on Mars, which doesn't have a particularly dense atmosphere or a magnetic field. But it certainly helps have a dense atmosphere, and it really helps have a dense atmosphere that's either free atoms or small molecules, basically. And then finally, you got to be next to an active star that is actually kind of projecting out the charged particles that cause it. So as far as the magnetic field goes, Earth certainly has one. Anybody that's ever had a compass has a pretty good bit of evidence for that. You always see in kind of textbooks magnetic fields like this, and they always have these lines of force around it, and it all kind of looks nice and neat. And you kind of learn, maybe if you're a land navigator or somebody like that, you learn that the Earth's magnetic field is not exactly lined up with the poles, and that it moves around a little bit, right? But but it's certainly there, and it's actually a very strong magnetic field, which is really good for us because it keeps a lot of things away from us that might be rather harmful. Of course, as far as where the Earth's magnetic field comes from, it's still not entirely understood. All the details are really not understood, but the basic thing is the Earth has this iron core, right, this solid iron core, and then an outer core that's kind of more like molten iron, and they're spinning, they're rotating, right, because the whole Earth is rotating. And because they're at different densities, they don't rotate at quite the same speeds, and so you've got this differential rotation in there, and it acts in a sense like a dynamo, right? It acts like if you ever take a magnet and put it inside a coil of wire and start rotating it around, it'll generate a little bit of current, right? It generates a magnetic field because anytime you got a current, you have a magnetic field at right angles to it. So it generates the Earth's magnetic field. Of course, the Earth's magnetic field is not necessarily a simple or a static phenomenon either. It's constantly kind of moving around, right? Every once in a while it goes away, it flips its polarity, there's all kinds of interesting things that go on. But that's essentially this dynamics down in the Earth's core is what kind of causes those magnetic lines of force. And again, when you look at these kind of simplified pictures in textbooks with these field lines like this, it all looks kind of nice and neat. The reality of it is actually a little bit more complicated than that. If you could actually see lines of magnetic force, it would look like this. First of all, the magnetosphere of the Earth is huge, right? It extends very, very far out into space. It has this kind of structure to it, and this actually plays into the Aurora story because when that stream of charged particles comes from the sun, gets kind of captured and directed by the magnetic field, you can kind of begin to see here why auroras are more polar phenomena, right? Because those lines of magnetic force would tend to sort of guide things towards the polar areas. So this is, if you could visualize the Earth's magnetic field far out into space, it would look more like this. And in fact, if you could extend it really far out into space, you would see something like this. This is the heliospheric current sheet. And this is the extension of the magnetic field far out into space. Notice how it's rotated, right? And that's because the Earth's rotating, so the magnetic field is rotating with it, but the further away elements don't rotate at quite the same speed, right? So you end up with this kind of warped structure, and that's what guides a lot of that, kind of serves as a guide that brings those charged particles from the sun into the Earth. So magnetic field, gotta have one, or at least you should have one. And by the way, I mentioned this before, but the Earth's magnetic field is not quite as straightforward and simple as I think we sometimes think it is if you look at the Earth Science 101 textbook. This is actually a diagram that shows the strength of the magnetic field, and there's this big magnetic anomaly down here in South America right now, and nobody quite knows what's going on there. But it's also known that every once in a while the Earth's magnetic field changes polarity, right? The South Pole would become the North Pole and vice versa. And that probably happens over, every few 100,000 years. And we're just about due for one. So it could be that this is part of the process of this kind of to happen.
And they think it's starting.
Yeah.
There have been some indications.
That would really be a bad thing.
The computers are just losing.
Well, yeah, and because it's thought that the way it happens is the magnetic field goes away and then reforms itself, and we lost our magnetic field, computers would be the least of our problems. So if you've got any, if you're short on things you want to worry about and you need something, there you go. No charge.
Going out into my tin shed, stay out there for a while.
Yeah. Well, I'm gonna maybe those people with the
Helmets?
with the foil helmets maybe they're onto something. Anyway, so yeah, you got to have a magnetic field, or at least a magnetic field really kind of facilitates the formation of aurora that we think of. We also have an active sun, and by active I mean basically one that is spewing out charged particles, and probably any star will do this. if we think about what's going on here then, so here's a nice kind of, we've talked about the sun a little bit. There's a nice kind of cutaway view of what we think the inside of the sun looks like. Down here in the core, there's where all that nuclear fusion is taking place, all that energy is being generated, and then it radiates and convects out, and at some point it reaches this surface out here and is radiated out into space. And so it's surrounded by this kind of corona, right? This sort of envelope of superheated matter, right? And you probably, I don't know, maybe you perhaps remember from a science class at one time, there were 3 states of matter, right? Solid, liquid, gas. So there's this other state called plasma, right? And plasma is basically just gas that's been disassociated by temperature. So the electrons have been separated out. So what you have is a material that has this charge separation in it, right? The electrons, which have negative charge, are separated from the nucleus, the protons in the nucleus of the atom, which have a positive charge. So what the solar wind is, or what this phenomenon is the superheated plasma that's been pushed away from the sun just by the sheer force of all that heat. And it's traveling in this stream of charged particles, right? If it were cool enough that those particles could come back together, then they wouldn't be charged and there'd be no aurora. But in this particular case, they are. Also, there are all these features in the photosphere of the sun, flares and prominences, and all of those represent kind of discharges of energy out into this stream of material. So here's some of the elements of the active sun, right? These things on its surface that send out these charges of energy. And there's a nice view right here. This is actually ultraviolet. This is in ultraviolet light, and you can really just see the streams of material leaving the surface of the radiated surface of the sun. Here's one that's, I believe this is also ultraviolet. It's just colored a little bit differently. But you can see over here, there's clearly something going on here, and that's something called a coronal mass ejection, right? Every once in a while, a big piece of the corona just gets blown off of the sun. And if one of those coronal mass ejections happens to coincide with the Earth, come toward the Earth, it can cause a lot of disruption in communications and power outages. It's thought that one of the blackouts that happened in the 1960s, that the entire east coast of the U.S. got blacked out, was caused at least in part by a coronal mass ejection that overloaded the power grid, right? So these things can have some pretty significant energy associated with them. But they form this thing called the solar wind, right? Which is not wind in the sense of moving air. It's just a stream of charged particles. It's all those kind of naked electrons and protons carrying their charge, coming towards the Earth, and they get caught up in that magnetic field. Remember, that magnetic field is really big, extends way out into space. So they get captured and kind of directed towards the Earth by those magnetic lines of force because they are charged, right? So they get captured by that magnetic field. And because of the way that magnetic field is structured, it tends to direct the solar wind towards the poles, which is why we typically think of the aurora as either a northern or southern polar phenomenon, although it certainly isn't. You have these things called the aurora ovals, which are where those lines of force kind of meet each other, and that's where they would tend to direct that stream of material to. So active sun. Also, you see a correspondence between auroral activity, the AA index is how many auroras there are basically, and sunspot numbers. So in this graph right here, which only goes up to the mid-90s because I couldn't find one any more recent than that, you have the AA index and the sunspot index, and that's in yellow. And you see there's a pretty close correspondence between these things. So there's probably a relationship between these, and that's probably one of the reasons why we're starting to see more auroral activity now, right? Because there's active sun, there's sunspots, there's all that stuff. Okay, so you needed 3 things, right? We got a magnetic field, we got a solar wind, charged particle stuff, and you have to have an atmosphere because that's where the lights come from, right? If this stream of charged particles just arrived at an object and there was nothing there for it to kind of interact with, you wouldn't get the aurora phenomenon. So The Earth has a rather dense atmosphere for a planet of its type. And as you can kind of get an idea from this photo from space here, it kind of has a layered structure to it as well. If you just want to know what the atmosphere is made out of, the majority of it is nitrogen. It's molecular nitrogen, N2. Second biggest constituent of it is oxygen. Nitrogen and oxygen together, about 98% of the atmosphere by mass. This other little sliver over here is, stuff that doesn't react with anything. Carbon dioxide that we kind of wish was not as much, at least wasn't increasing in volume, and a few other things. But it's nitrogen and oxygen that we really want to think about here, because to a first approximation, you can think of the Earth's atmosphere as just being nitrogen and oxygen. It's a good thing, by the way, that it's this much nitrogen and this much oxygen, because if it was that much oxygen and that much nitrogen, the first time anybody ever lit a match, the entire world would burn down, basically. So it's kind of good that, this is how the atmosphere is situated out. So this is compositionally what the atmosphere is. It's kind of has this layered structure, as you can kind of see here. And it's those layers that are really part of the Aurora story. So if you kind of look to the layering of the atmosphere, at least in a sort of a first approximation, down here at the bottom is the troposphere. That's where we are, right? Most of us will probably never leave the troposphere. I don't plan to anytime. Lowermost part of the atmosphere is where most of the atmosphere actually is, right? It's denser down at the bottom because gravity pulls it down. And then on top of that is the stratosphere, which occasionally people make it up into, and very high-flying aircraft and things like that. And then there's this stuff up here. And the Aurora story actually kind of happens tens of miles above the surface. Up here where the atmosphere is relatively thin, and in some cases you're almost in space, really. There's so little up there. But that's kind of where you see the Aurora phenomenon. It's up here in the mesosphere, basically, up here in this part of the atmosphere that's very thin, but still largely composed of nitrogen and oxygen. So here's a view of an aurora from space. This is actually from the space station, right? That's that little robot arm thing they use to grab stuff. And so this photo was taken from this sort of gondola thing that hangs from the bottom of it. And if you look at this, you see how there's kind of a verticality to this, like it has depth to it. And you can also see that depth seems to be associated with the coloring, right? It's red and then it's green, and there's an orderliness to it. And that is due to the structure, the composition and structure of the atmosphere. So where does the light come from? Here's where you kind of get into, a little bit of eye glazing. But basically what happens is, right, here's our atom, right? Atom, charged particle comes into the atmosphere, interacts with the atom, and what it does is it excites the atom, right? It causes that electron to move up to a slightly higher orbital state, right? It absorbs a little bit of energy, but it doesn't like to be there. Nature does not like to be at higher energy states. It's like the rest of it, it's lazy. And so that thing falls right back down, and in order to fall back down, something has to happen, and what happens is it emits a photon, right? So that's how all light works, basically, or at least as far as I know. I mean, if you look at what's really happening in these light bulbs up here, that's kind of the same thing is happening, these excitations and emissions and all that sort of stuff. So here's our atom in its excited state. There's the electron that's up in a higher energy state here. I have to bite my tongue not to refer to these as orbitals, because that's how I learned it back in the school days, and that's not what they are. And then there's our electron going out. And the wavelength of this electron, that as it's emitted, is what determines its color, right? So here's the emission spectra of oxygen, and you can see it has emits a little bit of blue light, right? A lot of green light, a little bit of red light, some infrared light, but it's a relatively simple emission spectrum, but you can kind of see where some of those colors are coming from. This is nitrogen, and nitrogen, remember, is a molecule, right, in this case. So this is atomic oxygen. It's just an oxygen atom, right? This is nitrogen, which likes to be in a pair, right? It likes to form anthropomorphize here, likes to form molecules, right? And molecules are just way more complicated than atoms because there's two things there. So they're doing all this quantum nonsense, but they're also stretching and bending and all kinds of stuff. Anyway, but you can still see blue light, right? Red light, a little bit of kind of yellowish light there. So this would be the emission spectrum of excited nitrogen. So this is what excited oxygen looks like. This is what excited nitrogen looks like. And when you start looking at what's up in the thermosphere then, right, here's composition of oxygen with altitude. You can see at higher altitudes there's more oxygen than there's nitrogen. Not very much. The particle density per cubic centimeter here is still, you know, a billion particles sounds like a lot, but it isn't, right? And then as you start getting to lower altitudes, it starts to kind of even out a little bit. And so you can, if you kind of just picture in your mind's eye all this emission taking place at various altitudes, right? So here up at the highest altitudes where it's mostly oxygen, we're getting atomic oxygen emissions in red. As we move down into the atmosphere a little bit further, where there's more nitrogen, we get some nitrogen emissions, right? What happens in the case of oxygen is higher altitude atomic oxygen gets excited. It starts shooting out photons that start exciting the oxygen below it, which is mostly going to emit in the green then. And I've got to admit, I'm not totally sure exactly why that happens. I'm still kind of working on comprehending that. But the basic result here is that you get this kind of layered effect of color emissions, right? And so when you think about that in terms of the auroras, right, the reds are from monatomic oxygen, you know, oxygen that's not a molecule, or a little bit from nitrogen. The blues are mostly from nitrogen, the greens are mostly from oxygen, and they form this kind of layered structure to it. So when you think back to that video we looked at, and you can kind of see that shimmering layer, you can imagine that's the result of these particles penetrating into the atmosphere, exciting the molecules. They radiate out in all directions. That excites other atoms and other constituents, and you end up with this depth of, you know, these kind of deep color bands that are following those lines of force, which are constantly moving, right? And so that's what kind of produces that motion. It's this kind of fluctuation of the Earth's magnetic field and this emission of light. So it's possible to get lots of different colors. I think this actually, Jan, I think you sent this around, didn't you? This orange. There's even observed to be orange auroras, and for a long time people were kind of wondering, or at least there was a debate about what caused that. Turns out that's not an emission, it's just an optical illusion from seeing a mixture of these other colors. But you can get a variety of different color types. Okay, so that's kind of the science, I guess, behind auroras. As we've seen, there's a relationship between solar activity and aurora activity. So here's solar activity going back to 1965. You can see it's very periodic, right? It follows, I don't know, about a 22-year cycle or something like that. We were in a quiet sun period for most of the late 2010s. Now we're kind of into a more active sun period. So this would be solar cycle number 25. And one of the things I find kind of interesting here is the red line is the forecast for what was expected from solar cycle 25. There's a lab out just outside of Boulder, Colorado called the Space Environments Lab, and where they do this sort of prediction, right? And this is what they were predicting for the current solar cycle. This is what we're observing so far. It's actually well above the line, and that probably helps explain why we're seeing auroras in places like Stillwater, Oklahoma. That the activity is more than what was expected. And if it continues to kind of follow a similar trajectory, we could end up with, you know, something like this. This was kind of a doozy back in this particular cycle. Okay, so there is actually a kind of a space weather associated with this. Like I said, the lab just outside of Boulder does these aurora forecasts. I also had linked to this one because I wanted to look at what the current aurora forecast is. Unfortunately, maybe we can look at it after we're done. We can go to the website. But you see something like this. This was the likelihood of aurora. So this was, I did this on the 9th, which is what, last week? Last Thursday? And this was where the forecast was. So you can see it didn't quite get down, the view line didn't quite get down to us. If you were in, I don't know, southern Canada, maybe a little bit of northern Minnesota, you might have seen it a little bit. But you see this line dip down, you know, like so. That means then probably we'll be able to see something. Okay, well that's a little bit about the, like I said, about the science of the aurora. We think of it as an Earth thing, but actually it's been observed on many different planets. There's a nice shot of the Earth's aurora. There's Jupiter's aurora right there, which, you know, has all the elements, right? It's a very dense atmosphere, very powerful magnetic field. It's getting solar wind too. There's Saturn right there. You can see another one. Just recently, aurora activity has been observed for the first time on Uranus. Uranus is kind of a weird case, right? Because it's sideways, or it's kind of tipped, right? The poles are not really, they're not really, they're aligned with the ecliptic, not normal to it like most of the poles are. So it looks a little bit different, but you can see aurora activity on Uranus as well. Okay, so that's, like I said, that's the science of the aurora. And as you can probably imagine, people have been observing auroras for a very long period of time, and they've been pretty inspirational sights. So quite a lot of art and expression of various types comes from aurora. My original title for this was actually a line from a poem. I eventually kind of modified that, but there's some really interesting aurora poetry. I thought this was a really nice one. Angelic view of night, I thought was a very poetic line. But it's been the basis for quite a lot of myth and art and literature of various types. One of those things is I hesitated about whether I should inflict this on you, but I decided I would. My all-time favorite poem is by a poet named Robert Service in The Cremation of Sam McGee. Anybody ever know this poem? No? Heard of it? It's a poem about two people in the Klondike Gold Rush, and one of them is freezing to death and makes his friend, Sam McGee, is freezing to death, and he makes his friend promise him that he will be cremated because he's so tired of being cold. And so he dies. Sam's friend, who is never really named, finds an old boat on the margin of a lake. This painting right here was supposed to show it, and puts him into the boiler, fires it up, and figures he's done with the job. He goes to open it up later, and Sam is in there warm for the first time since he left Tennessee, and happy, apparently. But anyway, the prologue of the poem, right, is, you know, the northern lights have seen queer sights, but the queerest they ever did see was the night on the marge of Lake LaBarge when I cremated Sam McGee. So if you ever get a chance to read this poem, I strongly recommend it. Anyway, there's also quite a lot of legends associated with it. And as you can probably imagine, those legends, they mostly come from more northern places, right? Because that's where the lights would be commonly seen. Some of them actually, one of the more prominent ones is from the Sami, who are the Laplanders, native people from Norway, I guess, and Finland, herdsmen, right? Have lived in the Arctic lands for, you know, probably millennia, and had legends about it. And one of their major legends is the firefox, which their word for the aurora translates into firefox. And the firefox is a somewhat malevolent creature in the Sami legend. It's interesting that some of the European legends about the aurora are rather negative, right? It's a negative thing. But I kind of wonder if this is, one of the browsers is called Firefox, right? And I kind of wonder if that's where they got the name from. Another legend from the same people is Nikija, who was a young woman that was carried off, basically, by the Aurora. There's another legend of two brothers who are herdsmen, and one of them goes out and starts taunting the Northern Lights, and they kill him. So it's considered a somewhat malevolent force in there, at least amongst these groups. Here's one for Iceland. Obviously, would have a Aurora connection. Pretty easy place to see it. In Iceland, the Aurora is often associated with the spirits of the dead, and often considered, again, somewhat malevolent, to the point where they actually have this rune, I guess you would call this figure here, which is supposed to protect you from the spirits of the dead. And you actually apparently see this sometimes even in tattoos. That you'll see people that have this in Iceland with a tattoo of this. I doubt real seriously if they're really thinking it's going to protect them from the spirits of the dead. But when I was looking at this, looking this stuff up, they actually showed some pictures of usually like teenage girls that had this tattooed on their arm, basically. So I guess if you're going to Iceland and you want to get protected from the spirits of the dead, this is something to take with you. There are Aurora legends among North American native groups. Again, mostly kind of the ones that would be Arctic, right? So like Inuit and groups like that. And they mostly associate the lights with kind of mythical creatures in their legends. And they tend to be more benevolent, right? It was kind of interesting to me as I read all these stories. It's like the European ones, even some of the northern, like Celtic and Northern Britain ones, they were like malevolent. The lights were a malevolent force. Among the North Americans, they tended to be a little less so. There are some legends from Asia as well. Interestingly, in China, they tend to be associated with dragons. And you can kind of see why, right? I mean, that kind of looks like a dragon. Right? That kind of looks like a dragon, basically. So they tend to be associated with celestial dragons. But probably the weirdest story that I took out of all this, did any of you remember this TV show,
Yeah.
Northern Exposure? I don't know, some of you it may have been before your time, but it was this story that was this show that took place in this weird little town in Alaska, and all the kind of eccentric people that lived there. But there was an episode where some Japanese visitors had come to conceive under the Northern Lights because it was supposed to be lucky. And this actually started a false legend. This TV show started a false legend. I mean, there had been an idea in Japan that the Northern Lights were lucky, right? That they were a sign of good fortune, but there was nothing in Japanese mythology or folklore that if you conceived under the Northern Lights that your child would be favored, right? That just so happened that the writers of this TV show decided that they would, and it's become a problem in some of these places. There are places in Alaska where they actually are like finding people,
Conceiving.
attempting to conceive under the Northern Lights because they have come to think that this is lucky, right? And apparently you can't just be in the hotel, you got to be outside. So,
Not so lucky if you're freezing to death.
well, I don't know. You gotta really, really want to have lucky kids. Is all I gotta say. But anyway, but this came about largely because of this. And I had heard that story. But what's weird is I'd heard that story before. I heard that in Japanese folklore, this produced. It turns out it's because of this TV show. So this is probably the oddest thing I learned in thinking about the Aurora. A lot of art associated with it. This is actually cave art. This would be, well prehistoric cave art. This is from a cave in France, and this depicts the Aurora. Here's some more contemporary art that kind of shows it. I thought this woodcut here was really interesting. So,
Oh, that looks like a bird.
that does look like a bird. And I figured this would be a good place to kind of stop here. But
Where is that?
I have no idea where that is. But that's an actual, that's not touched up, that's real. So,
Wow.
questions? Comments?
So, I've got a question.
Uh-huh.
So you said that you can see these in like Texas or Oklahoma. Why would you be able to see it that far south but not in Kansas like those people?
Oh, you can see them in Kansas. Actually,
At the same
again,
time, I mean,
yeah.
Because people weren't imaging at that time in Kansas.
Yeah.
You've got to be out there seeing this thing, and they're temporary, they don't last forever. I mean, they're 5 or 10 minutes long and then they're gone. So if you're not out there at the right time, getting these images. But generally, if you see them that far south, yeah, they're around here.
Oh, this is Alaska's Geophysical Institute. The one I want is NOAA. Although the Alaska one's probably pretty good. Yeah, there we go. So this is a 30-minute forecast. So here's the current forecast. So here's the places where the Aurora activity would probably be the greatest. You can see it's pretty much up around the poles now. This is the southern hemisphere.
How many people in this room have seen Aurora?
I remember a teenager in Michigan, spectacular, probably in the 1950s.
I've never seen a good one. So, again, that's on one of the things that's gone on my... I thought I was going to be able to see one once. I was on a trip to Alaska, and we spent the night at this place called Tulik Lake, which was a research station. And it was, I don't know, August, I think. They were just about ready to shut this place down for the winter. But it was, night was like, I never really got dark, right? It was north of the Arctic Circle, never really got dark. And so you couldn't, and I thought this will be my chance, and it just never got dark. So I ended up
What's
sitting
being used to identify that place of Aurora? Is there some ground-based measurements that are saying, hey, we have a high reading of the solar wind, or?
I think this comes from satellite data, actually.
So the satellites are picking up the Aurora.
I think what they're actually picking up is the energy, because here they give the energy disposition in ergs per square centimeter, right? So that would probably be I don't know, maybe details. So this is an empirical model. Okay, so it uses solar wind velocity and the magnetic field measured at the L1 orbit position. So apparently there's
That's pretty far out.
yeah, but it's measuring the magnetic. Of course, the magnetic field is huge, An estimate of viewing probability is derived by assuming a linear, you should never assume linear relationship, to the intensity of the aurora. Validated by the UVI, the ultraviolet imager. That's a thing that's on, UVI is on a satellite called GOES, and it's a polar orbiter, so it orbits over the poles.
GOES?
Yeah.
So here's some more information if you want to get it.
Mhm.
I don't know. Yeah, this looks like it'd be fun to read. So anyway, yeah, that's where that, I think that's where that comes from. So there's a... Oh yeah, so there's the power. That's basically just a Maxwell's equation calculation. Anyway.
Some middle school math there.
I don't know.
Play the play button.
Play the play button? Oh, there we go. So when is it going to get, yeah, we might get one.
physically they are present even during daylight, you just can't see them.
Yeah.
The particles
Yeah.
are still doing that.
And there's pretty much always, they're pretty much always there. That's the other thing about them is they're not always easily visible, but there's always that interaction going on.
The sun's always shooting stuff out there and interact with the atmosphere and magnetic. So, yeah.
All right.
Do we feel it happens mostly in the northern hemisphere because there isn't a lot of people down in the southern hemisphere to view it?
It's probably has something to do with it, yeah.
I think is there a strength difference between the northern hemisphere and the southern hemisphere?
Well, let's
Magnetic field. I thought that the northern hemisphere had a stronger pole than the southern hemisphere. I don't know where I get that.
Isn't like every line has to go to another,
Yeah.
the other pole?
Okay.
I don't
Yeah.
know.
I don't know. That's a good question, but
It seems
Yeah.
pretty strong there.
Ever
But maybe they're more dense. I
heard
guess.
people from Australia, or what would that be, Southern Africa?
yeah, there's
South America?
There's South America,
Mhm.
there's Africa, there's Australia, there's New
Um,
Zealand.
You know, talking about the Aurora.
Mhm.
Of course, they claim their aurora is better.
Oh, really?
Maybe from what Gary
They also
said.
think their beaches are better.
Different sand.
Well, I mean, you can
I don't
look
know.
at that.
Thank you, Doug.
and see that the southern.
All right, well, yeah.
One quick announcement. Banner Creek Science Center, everybody knows up in Holden, has always had an observatory called Banner Creek Science Observatory, or Banner Creek Science Center Observatory. It will heretofore be known as the Ford Observatory.
Okay,
Yeah, that's good.
that's good. That seems appropriate.
Ford,
Mike
Yes.
Ford.
like trucks, vehicles.
Yeah, Mike Ford was very active.
Oh.
Are they, did they have
He's passed away.
a kind of a plan for continuing the work there?
Corporate.
Somebody you know,
No.
Person, okay.
by the first name of Brenda, is now called the